dividing by a square root or a radical. And when we divide by a square root, we don't want to leave a radical in the denominator. But let's take a look at one of the fundamental properties dealing with square roots, and maybe that will help you think about how to simplify radicals and then eliminate a radical in the denominator. If I have, for example, the square root of 3 divided by the square root of 9, I can apply the property that says that's the square root of 3 over 9, which would become the square root of 1/3. Now the square root of 1/3 I can rewrite as the square root of 1 over the square root of 3. Square root of 1 is 1 times the square root of 3. Okay, so I can simplify it first. But now I have 1 over the square root of 3. And in math, we don't like radicals in the denominator, so we do something called rationalizing, which means we multiply the denominator by whatever this radical is. So I take the square root of 3. Remember, the square root of 3 divided by the square root of 3 is like multiplying it by 1. And I can multiply anything by 1 because I haven't changed it. So now when I multiply these, I get the square root of 3 over the square root of 9, which is going to be the square root of 3 over 3. And actually, you could have seen that back here. The point I wanted you to see is that if you have the square root of A over the square root of B, you can rewrite that as the square root of A over B, and vice versa, whichever way makes it simpler. So now let's take a look at a few examples of simplifying and applying this property. So here I have the square root of 3 over the square root of 48. So I can apply the property. That gives me the square root of 3 over 48. You can put that in your calculator if you need to. And when you do that, you can convert it back to a fraction. You would get that this is equal to the square root of 1 over the square root of 16, because this is 1 over 16. So then the square root of 1 is 1, square root of 16 is 4. So simplified form for the square root of 3 over the square root of 48 is 1/4. Number 2, if we apply this rule, the square root of 12 over 4, 12 is divisible by 4. It just gives me the square root of 3, and that's my answer. Number 20, or number 3, I can write as the square root of 20 over 5, which is the square root of 4, which is 2. Now number 4 isn't going to be quite as nice. That's going to give me the square root of 8 over 100, which reduces to the square root of 2 over 50. So now I have the square root of 2 over the square root of 50. I'm going to multiply by that radicand, square root of 50. That gives me the square root of 100 over the square root of 50. Or excuse me, not the square root of 50, over 50, because we rationalized that, so the radical's gone, over 50. So the square root of 100 is 10, so that gives me 1/5. Next, I have the square root of 15 over the square root of 125. Now I'm going to take a different approach to this. I know that the square root of 125 can be broken down into the square root of 25 times 5, which becomes square root of 15 over the square root of 25 times the square root of 5. Now we know 25 is a perfect square, so that means the square root of 15 over 5 root 5. Now when I want to rationalize this, I need only multiply by this radical. So I'll multiply top and bottom by square root of 5. So 15 times 5 gives me the square root of 75 over 5 times the square root of 25, which is 5. So I will have the square root of 75 over 25. Now the square root of 75 can be broken down into 25 and 3. So I have the square root of 25 times the square root of 3 all over 25. So I get 5 root 3 over 25, which is root 3 over 5. And again, you could have simplified that by applying that property. I just wanted you to see a different way to do that. Again, for number 6, I can look at this as 6, the square root of 6/8. I can reduce that to the square root of 3 over 4. Okay, so now I have the square root of 3 over the square root of 4, which gives me root 3 over 2. Number 7, now I have a constant or a coefficient in front. I can still apply the rule and reduce this to 3/4. Then I will have 4 times the square root of 3 over 3 times the square root of 4. The numerator stays 4 root 3. The denominator becomes 3 times 2, or 6. So this is 4 root 3 over 6. Number 8, when I look at number 8, again I see that I have that property 3 over 27. You might recognize that is 2 root 4, 1 over 9. So that becomes 2 times the square root of 1 over 4 times the square root of 9. Square root of 9 is 3. So I have 2 over 4 times 3, which is 2 over 12, which becomes 1/6. Okay, so a couple things to think about. One is applying that property that allows you to simplify those radicands before you rationalize. The other way is just to go ahead and rationalize and simplify it later. And you can choose whichever you want to do. Number 9, if you look at it as 2 over 2, which is 1, you can just actually cancel those. Let's do that. Let's make it as simple as possible to start with. Then you have the square root of 3 over 12, which becomes the square root of 1 over 4. That becomes the square root of 1 over the square root of 4, which is 1/2. Again, number 10, we can just go ahead and cancel those coefficients in the front. Now I'm going to write this as the square root of 6 over 27. I can reduce that to the square root of 2 over 9 because 6 is divisible by 3, 27 is divisible by 3. Then to further simplify this, I have the square root of 2 over the square root of 9. That becomes the square root of 2 over 3 because I can simplify that radical. Now remember, you don't want to have a square root symbol in the denominator. You have to do what's called rationalizing that. A square root is not a rational number. You want to try to get an integer because that's a rational number. If you look at number 11, hopefully you recognize pretty quickly that 16 is a perfect square, so you can just say 4 times 4 in the denominator. 3, hopefully you recognize that 20 is the square root of 4 times 5. So I get 3 times the square root of 4 times the square root of 5 over 16. 3 times the square root of 4, which is 2, times root 5 over 16 gives me 6 root 5 over 16. Number 12, again, I can cancel those 3's. Write this as the square root of 20 over 36. And then I can reduce that to, let's see, 4 goes into both of those, so I can reduce that to the square root of 5/9. Again, write it as the square root of 5 over the square root of 9. Square root of 9, 9's a perfect square, that gives me root 5 over 3, as we're simplifying these radicals. And that is all of the examples I have for actually simplifying these radicals. There are 4 videos that deal specifically with how to handle these radicals, whether you are just simplifying, adding and subtracting, multiplying, or dividing. These are all important when you are looking at these special right triangles and how we solve them. Thank you for watching.